How's it going, everybody? In this video, I'm going to be walking you guys through a high-level understanding of how the wireless section for the CCNA comes into play. And in a few subsequent videos to this video, I'm going to be walking you guys through how to get a Cisco wireless 2504 controller operational, a 3702 access point operational, and configuring a Cisco 3750X switch to be the intermediary device to get all these devices to talk to each other. We'll join the 2504, we'll join the 3702 to the 2504, and then a video after that we'll create a SSID on the 2504 that the 3702 will learn about, and then broadcast that network to surrounding devices. And then we'll be able to join that particular SSID, get a DHCP address from it, DNS information as well, and then be able to reach out to the internet if we so choose to do so. So with all that being said, let's talk at a high level about what we're going to be doing, because if you don't understand the concepts of how wireless comes into play and the pieces to it, it can be a little daunting if you've never dealt with it before. So first thing I want to do is lay out the specifics to that. So we're going to draw out the first thing, which is known as the distribution system. The distribution system is analogous to the switched network. What is the switched network? This is where your 3700s, your Cat 9Ks, your Cat 3600s, that's where all of your regular Catalyst switches are going to sit. And then, so you have your switch environment set up. So we're going to draw just a really basic network. 3 switches. We're going to draw what could be commonly referred to as a collapsed core. So the distribution and core of operations sitting on the same device. And then we're going to run some cables down to this switch. This will be your access. So this will be your access switch. If I could right, that would be great. Now the collapsed cores also can be connected to each other like this in some capacity, probably with a port channel. And there's going to be some uplink connectivity to some other stuff, but that's kind of irrelevant to us at the point. So that's the wired network that most of you should be, at least at the CCNA level, familiar with. The architecture is kind of irrelevant. So the next thing that we're going to be taking a look at is going to be understanding the wireless architecture that goes into play with this. So there's 2 different types of access points that are out there. The first one is referred to as the autonomous. I'm going to put just auto for short. And then you have the lightweight. The autonomous AP is an access point that has its own dedicated operating system, and you will log into that device and can create SSIDs, pre-shared keys, authentication mechanisms like that, and it will automatically broadcast. Well, I shouldn't say automatically. The idea for it is to be a standalone device. So if you have a location, for example, like your home network, right? That's considered an autonomous AP in most cases. It's going to be a standalone device, right? It's going to be wired into your existing network infrastructure. More than likely get its power through power over Ethernet, PoE, and it's going to get its SSID information from itself, right? It's going to configure everything itself. And then it's going to advertise wireless networks. The lightweight AP is also going to be connected into your wired environment and connected via PoE, power over Ethernet. However, the lightweight access point is considered to be a child in a parent-child architecture or parent-child model. The parent actually is the wireless LAN controller, or the WLC. The WLC also is wired into the wired network, but doesn't require PoE. It's got its own dedicated power supply. So the power over Ethernet connection to the lightweight access point is going to provide both the data and the power to the lightweight access point. Now, the controller on this particular interface is going to be configured with a management IP address of some value. I'm going to be using the 172.31.42.2 IP address here. And up here on like the collapsed core, you're going to have an SBI for VLAN 42. So let's put in here 42 SBI. So that's going to be its gateway. And what's going to end up happening is this guy here is going to use this SBI for its gateway, right? So my computer is sitting on a different VLAN than this guy, so I'll be using my core switch to route to that subnet. The wireless LAN controller will be handling a couple different functions. It'll be handling the management of all the controllers, as well as the data of the controllers. So what that means is that we have to configure the access point somehow to figure out who the controller is, where the controller is, all that type of stuff. And the way that you do that typically is through some sort of dynamic discovery mechanism. In this particular case, we're going to say DHCP. Now, one of the cool things about the AP discovering the controller is that if you're on the same subnet of the controller, the AP and the controller are on the same subnet, you can simply use broadcast to figure that out. You don't need to do anything fancy with it. As long as this port right here for the AP is configured as an access port, and this port here on the controller is configured for the controller is configured as a trunk link, because it is possible with a lightweight access point to configure multiple SSIDs, each one with a different VLAN, and you would then be landing that traffic on the controller. We'll talk about the concept of CAPWAP here in just a second. So what's going to end up happening is you're going to create a DHCP scope somewhere, whether it's on your switching infrastructure, if it's somewhere sitting elsewhere on the network, maybe your Windows server or Linux box is going to be running DHCP. And what's going to end up happening is your wireless access point, your LWAP for short, is going to reach out for a DHCP IP address. It's going to get that IP address through DHCP, and the BVI, the Bridge Virtual Interface, is going to get an IP address. Now, because of the fact that the BVI, in our particular case, is going to get an address on the 172.31.42 network, we're going to start off at .11 and work our way up. So the access point will get an IP address, and then we'll use multiple discovery mechanisms to try to find the controller. It'll go through broadcast connectivity, it'll look for the controller on its local subnet, which in this case, for our demonstration, that's what it's going to be doing. So, and how the discovery is going to end up happening. But there's other mechanisms you can use as well. If you can do protocol forwarding, you can use DHCP relay capabilities, there's a bunch of different options that are available to you, DNS, a domain name lookup, things like that you can go through. So if you're looking to dive into beyond the CCNA into wireless and really get into the weeds of how wireless works, I will be putting together a series of content that takes wireless deeper into how you would do things and all that fun stuff that goes along with it. It's a little bit of work. It takes some time to get through it, but I promise you, if you are interested in doing that type of stuff, to me it's well worth the effort. Now, what's going to end up happening is the DHCP process will give the access point an IP address, and at that point in time, the access point through the BVI interface will try to reach out to the controller. Well, I've already recorded the video that goes through and sets up the controller, the access point, the DHCP scope. I had a small snafu on the configuration here, and once I fixed the issue, then I was able to ping the controller, and then as soon as I did, the access point was able to reach out to it. So the access point will then reach out to the controller and try to join the controller. There is a certificate exchange process that goes through with this, very similar to that of which if your computer tries to reach out to, say, google.com or Facebook or any YouTube, there's a certificate exchange process to secure the communication between your computer and whatever it is you're trying to look at on the internet. That process is secure through certificates. Well, that process goes through here is very similar to what the access point and the controller do. They're going to do a certificate exchange process to make sure that the communication is secure and good to go. So you're going to want to make sure that the time on the controller and on the access point is the same or very close to each other. I will manually hard code it on the access point and the controller, but in a real world environment, you're going to be wanting to use Network Time Protocol or NTP. So that's going to be something you're going to want to do. So another thing that's going to be interesting about this, and we're not going to see it in the video that I've already recorded about the discovery process, but there's this thing known as the MIC, the Manufacturer Installed Certificate. And this is an important piece that screwed me up the first time I tried getting this to work. And when I say it screwed me up, I spent the better part of a couple of days Googling my way through Cisco wireless forums trying to figure out why I couldn't get an access point to join the controller. And after digging into it, it was as soon as I would solve one problem, another problem would get uncovered. And the problem that I ran into is, depending on how old your access points are versus what the controller is running, you might run into a certificate validity issue, meaning that the certificate might already be expired. So if you were to look at the MIC, the manufacturer certificate, it'll literally be an MIC underscore cert in the CLI when you do a show PKI certificates, show crypto PKI certificates on the access point. You'll have to go through this process, and you'll have to see what the validity period is for the access point. And on the controller, you can actually turn off the capability on that with the, what is that command? Off the top of my head, I don't remember. It is, I will have to see if I can't find it here real quick. But the command that you're looking to do is to turn off the check of the certificates. And if you run that command, what will end up happening is the controller won't look for the certificate, and if it sees it, it'll just pretend like it doesn't see it. And this is something that I've seen quite a few times happen in the real world, where you have access points, you do an code upgrade, stuff like that. Things do happen to where you have to turn off the expiry capability. You're just ignoring the validity period of the certificate. That's literally all you're doing. So anyway, what will end up happening is, once the IP address is received by the access point, it will reach out to the controller via CAPWAP. Which is the control and provisioning a wireless access point. That is the protocol that's going to be used. Once it does that, the controller will see the access point join, and then there's a check done on the AP versus the controller to see if the right version of code is running. So the AP has to be in the same version of code that the controller is. If it's not, the AP will download the code to the controller will, the AP will download the code from the controller, and then it will reboot itself with a newer version of code. You can actually pre-stage this if your access points have enough storage capacity. You can upload a new version of code to your controller, push that config down to your APs during the day, so that at night you can go in and reboot all your APs during a maintenance window, and then reboot your controller, and then the APs will join back up with the newer version of code instead of having to download the config on the fly. It's better to do it ahead of time so that you know for a fact it's going to work. So once this does, and the AP downloads the code and then reloads with the appropriate new code installed, the AP will then register again to the controller with the same mechanism that it did the first time. In this case here, it's going to be a broadcast. It's going to find the controller, it's going to join the controller, and it'll become operational at that point. So that's essentially the nuts and bolts to it. Then once that's done, then you'll be able to log into the controller, this guy right here, and you'll be able to create wireless networks. You'll be able to create DHCP scopes. You'll be able to do authentication mechanisms, and all of this stuff is going to be needed for any of you that are looking to do any of the configuration that is necessary for the wireless section of the CCNA. So it's pretty simple overall, the way that it's set up, but once you've gone through it a couple of times, it becomes makes a lot more sense. Now, as I work through my CCDE preparation and I'm going through the wireless section and I'm diving into these topics and trying to understand them better, it's becoming more and more obvious to me that, I'm still looking at it from a design perspective and not so much implementation. And so I don't want to stunt my forward progress and say, okay, I know I'm going to go after wireless. DE is my current goal, but I'm using the wireless learning process to go through that process. So it's been rather interesting. So there's a lot of additional capabilities that we can go through and do. One of the advanced things is going to be doing things like identity services engine integration, having a Windows AD implementation, so on and so forth, to play with all the capabilities that go into play with it. So there's a lot of cool stuff that you can do with it that takes some time to get used to and understand, but once you've gone through it, it's pretty straightforward for the most part. So the big thing is making sure that you have all of your steps in line. So the one thing that I don't want you to do is misinterpret this as it's easy, because out of the gate it's not. You need dedicated hardware for this. You need a controller. You need a lightweight access point that's compatible on that controller, and to be running a version of code that'll work. So that's one of the things where when I was going through the initial process for this, I had to start basically all over again. Like I was a brand new guy back, 15 years ago when I first started getting into networking. It's like, okay, let's take a break. Let's go back to the basics and learn it from basically ground zero and work my way up. So that's actually how I prefer to learn, is let's start at the basics and work our way up. So my goal right now, once this particular bit of content is created, it's going to be on YouTube. Obviously, if you're watching this video, you know it's on YouTube, but it's meant to provide anyone that's working on their CCNA and going through the wireless section of CCNA with at least a little bit of an understanding of how this process comes into play. Are there other ways of doing the discovery process? There are. There's multiple ways. I would definitely be familiar with more than one, but because of the fact of me walking you guys through the process of what we're seeing, that's going to be the main piece that I think you guys should know, which is why I'm putting together probably 2 or 3 videos, probably 3, if I'm just to get the CCNA piece up and running. They're not expecting you to be an expert in this wireless stuff, but I'm using this as a catapult, if you will, to knock out the rest of my CCNP wireless training so that I can move on to the next the next track, which is probably going to be security, but I'm not locked in on that, and I have a lot to cover with that. So I'm going through a lot of stuff. There's a lot of ICE that comes into play with this. So it falls right into line with my study path. I will be creating content for that stuff down the road. So that will be coming. It's just that right now my main focus is trying to get better in the areas of design that I need more technical understanding on, so that I know the appropriate way to approach these things. So I'm taking it as far as I think I need to initially, and then I'll be going through the individual areas of the DE to do this. And this is one of the things that you do. If you need to understand design, you need to understand the technology first before you can start looking at architecting and designing networks. So with that being said, that's pretty much the basics to what I wanted to walk you guys through in this video. If you guys have any questions, please leave a comment in the comment section below. If you haven't already done so, please like, share, and subscribe, and I'll catch all of you guys in the next video.